My name is Kazuki Tsujimoto. Today, I'd like to talk about pattern matching. First, let me introduce myself. I am a Ruby committer and as well as the proposer of pattern matching. And I'm also the author of Power Gem, which is one of the bundled gems. First, I'd like to beginning by giving you an overview of what I want to communicate in this session. Pattern matching has already been released a preview version of Ruby 2.7, but it is still an experimental feature and the specification remains under discussion. We are trying to correct real use case and so that we use them and we try to provide some convenient syntax. So I would really appreciate if you could try it and give us feedback. Okay, so this is agenda for today. First, I'd like to define pattern matching. What is its function? And next, I'd like to talk about specification. And finally, I'd like to talk about the thought behind the design. Okay, so what is pattern matching? Although it is difficult to define pattern matching in a few words, the slide shows quite good sentence taken from Haskell's tutorial. To summarize it for Rubyists, it is a combination of case when and multiple assignment, I think. So we extend case expressions for pattern matching in current specification. So we use case in instead of case when. So in this case, there is a variable in the condition. So it is similar to multiple assignment, I think. Of course, there is a difference between pattern matching and multiple assignment. Pattern matching can also check the object structure. So in this case, the pattern requires a given object has only one element. So this pattern match fails and move on to the next pattern. And this pattern match success because this pattern and the object has the same structure. What you have to pay attention to here is there is not only variable but value like 0 or 2. So pattern match can check object structure and assign its value to variable at the same time. It is a convenient feature of pattern matching. And pattern matching also supports hash. So in this case, this pattern has two keys. One is key A. It would have to be 0, and key X, it would have to be 1. But the given object doesn't have a key X, so this pattern doesn't match. And in this case, key A, it would have to be 0, and key B, it would have to be bar. So this pattern matches, and the bar is set to 1. This is a rough summary of pattern matching. Next, I'd like to show real use cases of pattern matching. This is an example of a session that may allow you to handle JSON data. If you look at the upper right of the slide, there is information about a person, and there is also a code printing age if condition met. And the condition is the person who is naming being Alice, and she has one child, and his name is Bob, and you actually get its age and print it. So the condition I have described can be written easily. So it is very beneficial aspect of pattern matching. Okay, so I will talk about specification. I described pattern matching uses case in for the syntax. And the patterns are line in sequence until the first one finds a match, and if no pattern matches, the else clause is executed. And if no pattern matches emerge and there is no else clause, the no matching pattern error exception is raised. And it is possible to specify if or unless to specify additional statement condition. So this is it is called a guard. The guard expression is evaluated if the preceding pattern matches. So in this case, the pattern takes two elements, A and B, and these two values should be different. So this kind of complex condition can be used when the guard is used. And as of previous version of Ruby 2.7, single-line pattern matching has been introduced. I think it is convenient syntactic sugar if you want to only one condition. Okay, so next I'd like to explain about several patterns. Ruby's pattern matching has 6 different patterns listed here. So I'd like to explain each of them one by one. First one is a value pattern. Value pattern matches the pattern and object compared with using triple call method. It is very much like case when. So there is 3 different patterns below, and all of pattern will be match. And next is a variable pattern. Variable pattern matches any value and bind the variable name to that value. So this pattern A is set to 0. Normally, variable pattern is used to refer the value to the later, but variable pattern can be used to check object structure. To do that, you may need to drop unnecessary values, and you can use underscore to drop the values. Since underscore is used to drop values in multiple assignments, so this feature can be accepted easily. So in this case, the pattern requires a given object has just 2 items. It doesn't care about what values the object has. And when we talk about variable pattern, there is one thing that we need to consider careful. That is a situation you have an outer variable with the same name. In this case, first A is set to 0, but in pattern, it will be just ignored and A is set to 1. So this behavior is sometimes acceptable, But if you want to pattern match against an existing variable value, then you can use caret at the head of a variable. So if you have been using Elixir, you are familiar with that. This function is taken from Elixir's pin operator. So in this case, the pattern includes caret A, that means 0. So this pattern doesn't match, and no matching pattern error exception is raised. And the next pattern is alternative pattern. This pattern matches if any of the pattern matches. I think it is pretty straightforward. And next is as pattern. As pattern matches the object to the pattern on the left side of the hash rocket. And if pattern matches, the object is assigned to the variable on the right side of the hash rocket. I think it is similar to rescue statement. Rescue statement also checks the exception class and assign the exception object to the variable. So in this case, 0 is an instance of integer. So match successful, and A is set to 0. And as pattern becomes increasingly more convenient as the object becomes more complex. So in this case, you have a nested array and for matching, which you can bind along the way and refer to that value to later. So it is a convenient example of as pattern. Next is array pattern. Array pattern is a bit different from what you might expect. That's because the array pattern is not solely for array object. So let me explain what matching is done by array pattern step by step. First, this pattern can be specified constant in the syntax, and the pattern and the constant compared with triple equal method. Normally, a constant stores a class object, so comparing by triple equal method means specified object, given object is an instance of a specified class. And if triple equal method returns a true, check if the object has a deconstruct method that returns an array. And if the object has a deconstruct method, then its return value will be applied to subpatterns of array pattern, and the whole of pattern matching is done. There are 3 types of syntax for array pattern. First and second are different in terms of using bracket or parentheses. You can use either one. And the third pattern, you can see it looks like array literal. This syntax is a syntactic sugar of first and second pattern that specifies a basic object. So that means this third pattern matches any object, not only for array object. So let me show the example of array pattern, an array pattern with array object. In case of array, the construct method returns array itself. Actually, this deconstruct method is a built-in method, so you don't need to define by it yourself. And there are 4 patterns in below. and all patterns match success. Okay, so let me explain what happens in first pattern. This pattern array is specified as constant. So array triple call 0, 1, 2 will be called, and 0, 1, 2 returns 0, 1 deconstruct method for 0, 1, 2 returns 0, 1, 2. So its return value will be applied to sub-pattern 0, asterisk A, 2. So pattern matches. And the second, third, and fourth patterns, sorry. Second, third, and fourth patterns are where constant becomes object or basic object. And in the first pattern, you can write these patterns without brackets. So if we want to reduce typing, you can. It is okay to omit bracket. And the next example is array pattern with other than array object. A typical use case of that would be, I think, struct. So this is an example of struct. The construct method for struct is defined as alias of 2A. When defined like that, the constructor return value of the construct method is equal to arguments for initialize method. So it is convenient for pattern matching. For example, I define color object below, and this color object takes 3 arguments RGB, which will be used to make color object. And if you create color object in this manner, the construct method returns 0, 10, 20. So if you use that to receiving color object, and try to identify the resulting color, you will get this code. In the first pattern, RGB value is 0, 0, 0, so that would be black. And in the second pattern is a case where R is only 255, so it would be red. So I think it is very easy to understand. Next is a hash pattern. This is a hash version of the array pattern. Main difference between hash pattern and array pattern is in array pattern, the construct method is used to deconstruct object. But for hash pattern, the construct keys method is used to deconstruct object. And there are 3 types of hash pattern. It is similar to array pattern. And this is an example of a hash pattern with hash object. And the construct keys for hash class is to return hash itself, like array of deconstruct key, deconstruct method. But the construct keys takes 1 argument, keys. This argument is hint information for performance, so I'd like to explain about it later. And there are 4 patterns below. So if you can understand array pattern, you can read this pattern without any problem, I think. But second pattern is needs some explanation, I think. this pattern has only one key, A, but given object has two keys, A and B. But this pattern matches success because hash pattern requires a pattern is a subset of the specified object. And in this pattern includes rest variable. It is similar to rest keyword argument. So rest will be B1, that is a reminder of matching. And the last pattern, nil is specified as a rest keyword. That means a reminder for matching should be empty. So this pattern will be fail. In hash pattern, you can omit braces too. And hash pattern provides a syntactic sugar that is just writing key. It is similar to required keyword arguments. So in this case, A is set to 0 and B is set to 1. Okay, so I'll explain about keys argument for deconstruct keys. First, let's forget about keys and think about implementing deconstruct keys for time class object. I think it returns a hash that includes year or month or others, which is elements of time class. And in Ruby 2.6, there are as many as about 40 items for such elements. But in contrast, there is a pattern, and this pattern specifies only year. So pattern just needs year, but the construct keys returns 40 items hash. So it is very inefficient, I think. So to improve that, keys refer to an array containing keys specified in the pattern. So if we use that, we can implement the construct keys that returns a hash only includes that keys. And it is we should note that there is a rest keyword, a rest variable in the pattern. Nil is passed instead as keys. So in such case, you must return all key value pairs. So let's review improved version of the construct keys. First, valid keys is defined. And then, if keys is an array, extract valid keys from keys argument and create a hash only includes that keys. And if keys is nil, return whole hash object. So as a result, if pattern specifies only year, keys argument is just includes year, and the return value of the constructor key is just includes year. So it is extremely effective. However, the implementation is rather complex than simple version. So there is a trade-off in terms of complexity and performance. So you should be care about. You really need to be use keys argument. Okay, so next I'd like to talk about design. So what policies were used by designing pattern matching? First is compatibility. I think compatibility is very important. And so what effects will be introduced by pattern matching? I think of two items. First one is a syntax because it introduces case in, and the other one is a namespace because there is a new exception class, no matching pattern error, and a new method like deconstruct and deconstruct keys. So we should be careful about their effects. So regarding syntax, we are not going to define new reserved words. So if we can define pattern matching within the existing keywords, there is going to be 100% compatibility, which is I was aiming for. Also, however, it will be lost if we introduce new keyword. For example, if we introduce new match expression, if user uses match like this code will be broken. So we have no choice but to extend the case expression. So next question is, what should we use instead of the when keyword? This keyword has some requirements. First one is it should be suitable for pattern matching in terms of vocabulary. And second is it must not be placed at the beginning of the expression. When I was first thinking about that, I think there was no new reserved words meeting these requirements, but I noticed that in keywords which is being used now. So some may not know about that, but Ruby has the for expression, which is legacy loop syntax. Have you ever used for in production? No? So it contains an in keyword that meets the requirements I described. So I decided to use case in combination. And next is about namespace. Unlike syntax, we can't maintain 100% compatibility for the namespace. So as for no matching pattern error, if no matching pattern error has already been used by user, it will not work. And as for deconstruct and deconstruct key methods, if user use that, if user brings the code from current version of Ruby to Ruby 2.7, it will work. But if user attempt to combine it to pattern matching, it may not work. So we should choose a name that is not currently used. In order to do that, we are trying to investigate code of all gems hosted by rubygems.org and check the name is used or not. But especially for deconstruct keys, I think it is a good name in terms of uniqueness. But name-wise, I'm actually it is not so good. So I would appreciate if getting some good idea from all of you. So feedback is welcome. And the next policy is be Ruby-ish. Pattern matching is a widely used function in statically typed functional programming languages. But as you know, Ruby is a dynamically typed object-oriented language. So it is necessary to combine these essence efficiently. I think there is two perspectives for that. First one is we provide a powerful array hash support, and another one is we provide a way to encourage duck typing. So array and hash are very important data structures for Ruby, I think. So as you know, these objects are given special treatment for Ruby within the context of multiple assignment or keyword elements. So we provide array patterns and hash patterns, and provide abbreviation and syntactic sugar to make it possible to use it natural. And another point is encourage duck typing. So we provide a concise syntax for duck typing. That means in this example, there are two patterns, and I believe most of users uses upper pattern rather than later pattern because this is simple. And if you use upper pattern, the object assigned to time variable should not be instance of time class. And the next point is we don't provide a way to match to make a match with arguments. So in this case, case keyword is deleted, and immediately try to make a match with arguments. I think it is possible to support that syntax, but checking if an argument is a specific instance of specific class is not for duck typing, I think. So I hesitate to introduce such syntax. And finally, there is future works. So since I don't have enough time to explain all, so I skip explanation, expect one. This is writing documentation. It is very important to write official document about specification of the pattern matching. So it would be helpful that a native speaker or someone who are familiar with English would volunteer to assist us. So from this year, Ruby's repository is migrated from Subversion to Git. So it is also a chance to show your activity on contributors page on GitHub. So if you are interested in joining us, please let me know. Okay, so with it, I conclude my presentation. Thank you for attention.